Hi, everybody. Thank you so much for joining us. I'm Oscar Keys. I'm the Multimedia Teaching Learning Librarian here at VCU Libraries. I'm aware we might have different folks from different places joining us today, but we're at Virginia Commonwealth University, and the workshop is our creative technologies space that's available for students and faculty to do all kinds of different types of creative inquiry. And I am so excited to be joined by my friend Adam Hyland over at the University of Washington, who's going to be talking to us about generative AI, specifically stable diffusion and a couple of other tools for making generative art, which I know is a very important and hot topic at the moment. And Adam is a PhD student at the Human-Centered Design and Engineering Department over at UW. And he is interested in the structure and nature of collaboration within and among systems characterized by high demands for reliability. He's a BA in economics from the University of Wisconsin-Milwaukee and several years of experience in software development and nuclear power plant operation. And I happen to know was quite wiki famous on the editing side of that. So I'm going to throw that in there too. And I have enjoyed every conversation I've had with Adam so far, and I'm really excited for the one for today. So with that, I'm gonna hand it back over to you, and I'm gonna take myself off of the spotlight and give it all to you.
Yeah, thank you, Oscar. All right, I'm going to share screen, which will stop that music. Okay, I'm going to get used to this crazy AI here, or AI UI rather. All right. So, hi, folks. We are all here because we are interested in AI glitch art, and I wanted to sort of bring a not quite a technically inflected perspective and not quite an artistically inflected perspective, but something in the middle, and allow us to sort of take a look at maybe what's happening in these tools that we just so happen to talk to with what seems like language. And I want to sort of like first give you a sense of like where the genesis of this workshop came. So last summer, some of you may not remember this. I'm not going to go through the whole history of digital AI art. There's a great history behind that, and there's some wonderful people who can talk about that. I'm not one of those people, so I'm not going to give you a poor history. But last year, there was a product called a DALL-E Mini, which was released, and many of you may be familiar with a service from OpenAI called DALL-E, which is their automated image generation service. And DALL-E Mini was produced as sort of a minimal implementation of that could be done in open source. It was created with much less training time and had much less fidelity, but it was also released online with relatively little compute resources required to run it. So pretty much anyone who had connection to the internet could plug into this and just build picture after picture after picture after picture. And I got a little obsessed. You can see from the left-hand side column here that I just started building out categories of images, patterns I found, things that I found. I'm sure it wasn't healthy for everyone, but it was at least fun for me. So I kind of want to bring you into where I was, what I was feeling last summer. And what I was feeling was the shock of the new. And when I find myself reeling from the shock of the new, I tend to return to books. I go and try to find a book and see if someone else had dealt with this before. And the book that I reached for is this sort of media studies classic called Gramophone Film Typewriter by Friedrich Kittler. And it talks about essentially how people, mostly in the European West, reacted to the invention of the gramophone and the invention of the film and the invention of the typewriter, these things that radically changed practice and moved it, as a lot of people thought, out of the hands of human beings or the mouths of human beings and placed it somewhere else. And we had to kind of deal with that. And there's this beautiful story from Rilke that is excerpted in this book, and this is immediately sort of in the shock of the gramophone, written in like 1919, and it follows this dashing and debonair European doctor. He's sort of like Nicolas Cage in National Treasure. He's got like a PhD in 5 fields, and he's a swashbuckler and a gravedigger and all that sorts of thing. And he has invented this device which will model the larynx of a dead human being. And if you blow through the model, it will produce not only the sound of that human, but their words. And because the story is German, they go and they dig up Goethe, the poet, and they say, and they take the model of the larynx after some sort of off-screen grave robbing, and they bring it to his study, the better to sort of have the sounds reverberate where he was when he lived. And they blow through it, and the doctor's country assistant, right? She's young, she's from the country. She reacts in alarm when the poet's voice comes out and the poet's words come out. And the doctor turns to her and says, "My dear, do not be afraid. It is merely the repetition of a possibility." And I love that phrase because here in 1919, sort of thinking about what it means to have sounds recorded, to have something that we thought sort of unseverable from human presence recorded, we have this beautiful and apt metaphor where we talk about it's a repetition of a possibility. And I think much of these generative AI tools are essentially repetitions of a possibility. And I want to kind of explore what that space looks like. So we have, I can, 3 goals for this workshop. First, as I mentioned at the very top, I kind of want us to think practically about these generative image tools and what it means to have a tool that has a natural language interface, where you speak to it with what seems like human text, because we're very used to working with tools where you type in some sort of non-natural language instruction, or you have some other way to interact with it, but ones where we speak to it are new to us. And I want to explore one way these tools are modified. For the most part, we're just going to use one model and we're going to play around with it a little bit, but I want to talk about one way that these tools are modified and that these modifications are disseminated and distributed. And third, I want to generate some weird art. So back up before we get into the demo here, and there's a lot of text on the screen, so read it, I guess, while I'm talking. This is a very strange moment to be in. So as I was preparing the slides this morning for this talk, I got an email from OpenAI saying, "Oh, hey, GPT-4 just dropped. We are going to do the live demo today at 1 p.m. Pacific. It will not hurt my feelings if you leave at 1 p.m. Pacific and go watch OpenAI demo this terrifying tool, but it's a sort of a sign that like this space is moving really fast. And not only is it moving fast in terms of what is available to people who have a considerable amount of power, but it's moving fast and it's being widely distributed. As I note on the slide here, this image up here, and we're going to generate a few of them, this image up here was produced essentially for pennies. And my interface to producing this image was a web browser. So there are not a lot of brakes on this train. And so we kind of want to play around with it and get a sense of what's going on here before, as I note here, before it becomes too difficult to sort of talk about how these images are working by relying on sort of the crudeness of the production or the inaptness of the production. All right. Before I do that, one last thing. So I have a link on here to a paper called Talking About Large Language Models. And this is from a researcher, a senior researcher at DeepMind at Google. And it is a really good broad audience introduction to what's actually going on inside these tools, aimed to getting you to wrap your sort of language around the right way to talk about how to think about what a large language model generates, how to think about how they're built, that sort of thing. So plug for that. It's free, it's on archive, go read it. So for this tool, there's no code required, but we're going to go and use a coding platform called Google Colab. I'm going to pop out of the slide here. I put in the slide a link to this particular UI. This is a community tool. It's built on GitHub. It is a harness for a variety of stable diffusion tools that change how the image works and give you a lot of control over what's going on. And the way that you would install it is you would come to this GitHub page, and on the page in the section for the README, there are 3 links here. There's automatic, Dream Booth, and Run Pod. Don't worry about the Dream Booth and Run Pod. We're just interested in the automatic. You click on this. This will open a Google Colab notebook, and you can copy it by clicking copy to drive. And if you're logged into Google Drive, that will copy it over there so that there are not that many changes. I recommend that if you are relying on this, that you copy it to your Google Drive, because this project is not one that obeys semantic versioning. So if you go back to the GitHub page, you'll see there's like a lot of changes happening, and they will push changes to this behind your back. So you'll log in to this if you don't copy it to your drive, and something will be changed, and maybe it'll be broken, and maybe the developer who broke it won't fix it for another 24 hours. So copy it to the drive. I've already copied this one to the drive. When you log into Google Colab, you have an option to use the free tier or use the pay tier. You can run this model on the free tier. It's very slow. If you pay, you can use, and I'll show you here, if you click on view resources, you can indicate what runtime type that you want. And in this case, we don't actually need the high RAM. In this case, if you want to use the GPU and you want to use a fast GPU, which we're going to, you will end up paying essentially about $1 an hour in order to operate this. So you copy it to the drive, you connect to whatever your resources are, and then we'll wait a moment while it allocates this gigantic processing unit sitting in the cloud somewhere, just devoted to the silliness that we're about to do. Once you're connected, you can either run these step by step by hitting Shift Enter or clicking here, or you can just run all of them. And this is going to ask me, hey, you want to connect to this Google Drive? So, don't do that if you think this is nefarious. We say yes to all of that because we're conditioned to do that. It's going to load up Google Drive. The reason why I use this one and not some other ones is just because it's really convenient to like generate images here and save them somewhere. It's really convenient to put models in here in Google Drive. There are other cheaper options that are available. The next thing it's going to do automatically is attempt to pull down the main repository. This thing is just sort of like a harness for it. Pull down their main repository, and then it's going to update that. It shouldn't have to do much there. It's going to keep chunking, and then it's going to come and say, hey, what kind of model do you want? This section's a little scary. If you have loaded this up and none of these are filled out, so it will just automatically download the 1.5 model. We are going to use a specific set of models. This is just a folder that I have. We're going to end up using the 1.5 model, but I just don't want to use their version. But if you don't do anything, this will just load the baseline model. This is loading another set of modifiers, and then finally it's going to start. What this will do is it will load up a machine running in the cloud, and then we'll expose an interface to us via this local tunnel. It will give us a URL that's going to pop up. And I've just got a user and password here. Obviously, you could take them and then log right into what I generated. This is having a sort of trivial username and password helps you if you're running these by yourself, because potentially, even though these URLs, you're going to see it in a moment pop up, even though these URLs are auto-generated, if someone guesses it or knows it, they can just log into your instance and use your compute time unless you have a password. And so people might just be spamming through all the possible URLs that this service can generate to look for someplace where they can, mine Bitcoins. So add a password. We're going to pop back here while that does its thing. So as that's loading, what we're gonna get, I should have loaded that before, but I was chatting with Oscar about drama. So as that's loading, you'll see a sort of image of the final pane here where it's going to say, this is how long it took to load. This is the embeddings that you have. We'll talk about that in a second. And here's the URL. And then the UI, the main UI that you're working with, is what you're going to see on the left. And I'll kind of explain some of these. We're not going to modify all of them just yet, but we'll see what's going on. All right, we'll check back in here. So it has now finished all these other steps. Now it's gonna fire this one up. This will take probably about 1.5 minutes. So if anyone has questions in that 1.5 minutes, feel free to ask them in the chat, and then we will be able to answer them. There are other implementations that you can use. I considered sort of sending out links to like a whole bunch of different ones. There are some that are more broken than others. This particular one is a pretty mature implementation. It's been developed pretty heavily over the last 6 months. There are other ones that are less mature. Those and you can reach out to me if you want to find one of those. Those have the advantage sometimes of being able to break them. So I will point us to a section where we can adjust some values in this generation, but we will be clamped to the appropriate values. We can't send in invalid values, and we used to be able to, but they realized that was a bug in their implementation. So we can't create images by cheating with that just yet. So, all right, still working. Let's go back to, let's see here. What do I want to talk about? I did not anticipate this dead air. So let's see here. So what we're going to do when that loads up is just take a look at a couple different things. First, I think we'll do is we'll try and generate something, just anything, and then we will try and get a sense of what's going on with the machine.
And actually, you do have a question in the chat, Adam.
Yeah. All right. Let's see.
And it says, iPhone
Oh,
asks, could you repeat what you said about the new version of GPT and explain what that means?
yeah. So there is something called, so GPT stands for, it's a made up term. It stands for generative pre-trained transformer. And the generative means that it's designed to produce text. The pre-trained means that it has been trained on a vast variety of things, and the transformer refers to the specific kind of tool that it uses in order to generate it. And GPT is a term that a company called OpenAI uses for their mainly for their sort of chatbot. So you've heard of ChatGPT, probably, or you've been forced to hear about it. And that is driven by a model called GPT-3 underneath. So it's a large language model that there is a sort of chat harness that is set up in order to instruct it how to do turn taking. You send a message, it generates text based on the combination of your message and its previous prompts. And when GPT-3 came out, it was quite a bit more powerful than GPT-2, like considerably more powerful, enough so that you had a whole host of people attempting to do things with image tool, or do things with language tools like build image generators that were not possible previously before. And there was like a lot of sort of joking about how GPT-4 was going to be 10,000 times bigger, or 100,000 times bigger, but nobody knew when it was going to come out. And so it comes out today, and as a matter of fact, in 11 minutes. All right, here we are. So we're almost ready. So I can sort of point you through what is happening here. So it's first thing here, it says loading weights, and then it gives you a portion of a hash. So it just says this is a cryptographic signature for the particular weights that you're loading, and it says where they're being loaded from. So this is loaded from the folder that I told it to load from. It loads, this is the Stable Diffusion 1.5 checkpoint, which is a very, very common, widely distributed version of Stable Diffusion. It then says it's creating a model based on this YAML file that it's got. This tells you how it's working, how many parameters it has. Most of these don't change. So this section here, if you load Stable Diffusion, is almost always going to do this unless something's weird. And then it tells you it's loaded 2 textual inversions. We will get back to that in a moment. And now fire up this link that it's got. User login. Okay, so now we have a Stable Diffusion checkpoint picked. This won't necessarily populate until we draw something, and we have this baffling user interface in front of us. And we've got a lot of different options. So Stable Diffusion is a name for a sort of host of tools and samplers that sort of operate iteratively. They start from a perfectly noisy image, and then they generate things slowly over time in order to diffuse toward a particular direction. So if we type in something like Apple, we'll fire that up. So we hit, and it's generating, hopefully. Sometimes if this is, there we go. Okay. So we've gotten to our first sort of like semantic sticky point, right? We said Apple, we asked it for an apple, and Stable Diffusion says, aha, I know exactly what you mean. Here is the Apple computer. So I'm like, okay, well, how about a red apple? We'll ask it for a red apple. Okay, now it's got okay. Now it says, all right, we're pretty sure we know what you mean. What if we ask it for a red apple computer? I don't know what it'll do. Okay, well, now it's not really red anymore. I suppose it's maybe red on the bottom, but it's decided, okay, we're pretty sure you want an Apple computer. So we know that we can offer prompts here. These down here represent different kinds of samplers. So you don't necessarily need to know what all of these are. You should know that each one of these has more than one gigantic paper associated with it by people working very hard to build faster samplers. So you can look up on archive probably papers for every single one of these. We're for the purposes of fooling around, we're not going to change too much. Down here you have this thing that says seed. And it's set at -1. What that means is it tells Stable Diffusion to generate a random seed each time it generates a new image, so that if we typed in Apple again, and matter of fact, we can type it right now. So we type in Apple again. The first time we got an image of what looked like a Macintosh screen with some sort of dialog box on it. Let's see if we get that again. Oh, see, we don't get that again. All right. Now, if we want to, we know that if this generates with this particular seed, right? So if we copy this seed and we say, all right, that's the seed that we want, generate this again. So lo and behold, you have the exact same parameters and the exact same prompt and the exact same seed, and you'll get the same image. If you change any one of these parameters, so we don't know what CFG scale is, but let's just say, this ought to be 26. I don't like the number 7, right? We'll move it to 26.5 and we generate it. We'll see what happens. Oh, that's not the same. Hang on. Now, this is sort of like a reminder that you can set the seed, but the seed will only produce the exact same image if every single other generation parameter is the same. If you change any of the generation parameters, but you keep the same seed, you're not moving infinitesimally away from that seed to something that's close to it. You're just essentially generating a whole new stream of random numbers. The same thing, whereas like if we change we'll move this back down to 7, not 7.5, because that will give us something different. Move it back down to 7, we'll generate it again. Still making sure that we've got the same image. Okay, same image. Now, if I change this to a slightly different seed, so the last digit of the seed, instead of being a 5 and a 6, we're gonna change that. We're gonna see what happens. Completely different. All right. So you should not consider the seeds that are showing up as something that varies continuously. There's a wide variation in what's going on, just based on a movement of one seed. Now that's real common in sort of the cryptographic world. There's sort of an expectation that a good seeding algorithm will give you a big change if you change one small value, but it's something that we're not necessarily sort of intuitively connected to. So we'll change this back to random. So we've got. Let's go back to a red apple. We'll generate one of those. All right, so we got a red apple. It's presumably done what we asked for, although that's not really a terribly great way to think about it. But let's say we asked for a red apple, but we don't actually want it to be red. We wanted to tell the machine that we want a red apple, but we don't want the color of the image to be red. So because you can have a black and white image of a red apple. So we have this thing called a negative prompt, where if the positive prompt is what you are pointing the iterative diffusion model to diffuse toward, the negative prompt is something you are pointing it to diffuse away from. So if we we'll just put the color red in the, the negative prompt and we'll see what happens. We've got it in the negative and the positive prompt, so it might just decide it doesn't know what we're talking about, and it in fact does. So let's say we want, let's see here, a sports car. And then we don't want a red sports car. Did I not spell that correctly? Oh, it's just got opinions about it. All right. Okay, all right. So it might have been inclined to give us a red sports car, but we told us we didn't want to. We were going to say we can put something in there. Here's an interesting thing: we don't actually have to have anything in the positive prompt in order to generate something. We can just have something in the negative prompt. We can just say diffuse away from red. I have no idea what this is or what it's supposed to be, but it is distant from red for this seed as far as this model is concerned. So we have this ability to sort of like point your text in a particular, or point your image generation in a particular way, or point it away from one in a particular way. Now, it's worthwhile to point out here that while we are interfacing this via natural language, right, we're using sort of words, or we can use words to put in here, what is being operated on once you get past the input is not necessarily natural language. So I have installed an extension for this tool, which will give you a sense of how the model is tokenizing the text that you put into it. So if I say something like a very, very, very tall beanstalk next to a castle, and I say tokenize this, it will hopefully load this up. Okay, and now it is indicated this is actually how these are broken up. Now it's nice because these tokens, for the most part, except bean and stock, break along words, but they won't necessarily. So the model here is saying, okay, I've got the first token A, I've got this next token, right, next set of tokens, very, 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 and then each one of these, and then we split bean and stock into two tokens. Whether or not that sort of maps to one particular idea is unclear until we plug it in. But these are what's being fed into the machine. So if you have, for example, if we just go all right, now we've given it this, not quite a word, but now it's now tokenized very into about 8 different tokens. And so what you are expecting, perhaps, that it would take what you see as something bound by these two spaces, even though it's not really a real word. And you would imagine that if you were to tell this to someone, they might assume that what you really wanted is a very, very, very tall beanstalk. You want it to be exceptionally tall. But in this case, it's might not know what to do with all these E's. Let's fire this up and see what's going on. Take the red out of the negative prompt. And generate. All right. Well, this is the world of AI art. That doesn't look like a beanstalk I've ever seen, but there it is. If we remove this, we maybe just say, all right, that's too much. We want it to be very tall. That's a little bit better. It's, you know, there's more of a sense of tallness, but that's still something interesting. So we have these positive prompts and we have these negative prompts, and we have these prompts are broken into tokens. And one of the things that we'll come back to here. One of the things that researchers realized when they were starting to build these systems was that that you could embed larger strings of tokens into one word that pointed to them. So you might train a model in order to produce a small set of tokens that represented, you know, a duck or a bear or something like that. And then you would say bear version 1.0, and you would type that right in. We'll get to that, how that works in a second. And that would load in someone else's pre-trained set of embeddings that would generate this particular bear. And we'll get to something very practical about that in a moment. So we'll go back to the slideshow. So you take a look at this picture, and do we notice anything missing? Probably not hard. So this picture is done with Stable Diffusion 2.0. This was posted on Twitter by one of the heads of Spility AI, and as a sort of an advertisement for their new product, right? Maybe we don't notice anything missing in just this one picture, but if we look over, how about now? I'll tell you what, a shiny nickel to someone in the chat who's got a guess as to what's missing in all of these images. And then I'll give you 20 seconds. And then One of them's missing an ear. That's true. That's true. This is something that's missing in all the images. Yes, it's very difficult to teach teach any of this about the linear perspective, but let's find out. So I'll tell you what's missing, and we'll find out why right when I. Stable diffusion is not great with hands. We just typed in hands into the prompt, and this is what you get. If we go back to where did my, there we go. Yeah. Teeth is also they're missing some of them. So yes. So they are all missing hands. So all of these images, which were used to sort of like demo how cool stable diffusion was, everyone's got their hands in their pocket or the hands are out of frame. And so one of the things that people realized was like, we might want to we might want to try and fix this problem. And as I mentioned previously, folks have been able to create embeddings, which are maps of one particular chosen word to a wide variety of tokens that are trained in the machine. And these embeddings can be a lot of different things. So in this case, you've got Alf up here, and then that is the Aflac duck. And you can also apply styles to images. So glitch core is a style that you can apply to an image, and all you would have to add is, glitch core, assuming you had the embedding installed. But we're going to talk about one of them called the bad prompt embedding. And this is one that I found last year. And so the idea was that stable diffusion is bad at hands. And folks were trying to find ways to improve output of human figures, specifically hands. And this model teaches something. Or this teaches something to the model, and it's invoked here with a specific keyword, as embeddings are. And I will also say that, like, it is worth paying attention to what the kinds of figures that are being used to advertise this particular embedding. And before I go back to Colab, actually, you know what? We can go back to Colab and we'll fire this up. So if we look to there we go. So when we loaded this up, it told us it loaded 2 embeddings. So bad hands 5 and bad image V2 39,000. Okay, we're not going to worry about that. Bad hands is a derivative of the bad prompt embedding. So we'll say, well, I want hands, but also we're going to put bad hands. We know in the negative prompt. So diffuse toward hands, but diffuse away from this embedding network of ideas of what bad hands look like. So we'll see what happens when we do that. Okay, that's not great, but it's an improvement. And so the idea here is strange if you think about it. Is that what would you teach this machine to diffuse away from if you found that it had the propensity to diffuse toward strange looking hands? And I don't think that's necessarily like a trivial question. And we might have a sort of guesses as to the answer. Yes, as Sage points out in the chat, we have in fact reached the uncanny valley. So this is what is being taught to this model. So what this person did, and I should point out, the only reason we know this is someone asked them. They advertised their model on Hugging Face, which is where a lot of these are disseminated. And I found out that about this. Well, they answer questions on there, and they basically said what we did was we created this prompt that you see here. They fed it into the machine, and then they took the images that they produced and they trained the machine on those images. So they said, associate these images that we produced with the term bad underscore hands, in this case, or bad underscore prompt. And then this is what the machine essentially diffuses away from. And we can, if you want, I'm not here, we'll take it out of the slideshow. So we can add this prompt right here, and we'll generate and see what's being produced. Generate another one. And the other thing is I'm generating these one at a time so that they're faster. So this would be an example. I don't have their original seed, so I cannot generate the exact original images they used for the bad prompt. But this is essentially equivalent. So they generated dozens of these, and then they took hundreds of hours of compute time to train the model to recognize these and associate them with a particular set of characteristics, and then they assign those set of characteristics to the bad hand. So it makes me wonder. We've got all that stuff in the positive prompt. What if we just put bad hands in the negative prompt? I don't know what'll happen. Let's make them fight. Well, now, isn't that interesting? No, I don't know what to make of that. This is not quite the same thing. The bad hands 5 prompt is generated from different things, but you have you end up in this strange space where there's no indication, like there's no way to make sense of this. There's no reason making ability that says if you plop this string of text up here and then this embedding in the bottom, that they're going to come to, I guess, what this AI system sees as a neutral value. I don't know. This is that does look like a default white guy. Speaking as someone who's spent a couple years looking like a default white guy, and perhaps still do. I don't know. But so we are in this kind of strange space where, like, if we look at this, and I think we ought to, and we think about sort of what is being trained into this model and how it's being trained. These prompts are a little harrowing, I think, from some perspective. Like, this is a very particular idea of what a human looks like and what is not okay for a human to look like. You'll see bad proportions, mutations, deformed, disfigured, like all these things. Like, if you even spent like a moment talking to anyone in the world of disability studies, like, you will see a prompt like this and go, "Whoa, this is something going on." But you could use the bad hands prompt without ever knowing this was how it was being trained. And I really only found out by accident. So if you go to the what I did was, when I found this bad hands prompt, I said, oh, well, like, that's great. Like, it's going to get rid of bad hands. I don't know how to use this stuff. So I plopped it right into the regular prompt. And then, well, we'll just see what you get. This one is actually less horrifying than most of them end up being. But I had put this in the positive prompt thinking, okay, well, it's like, bad hands, a person reaching into a car, right? And I figured, okay, well, that's how you get rid of bad hands. And instead, you just got this like really strange art piece, right? And so when I asked about it, they said, oh yeah, you gotta put that in the negative prompt, guy. And also was able to see in the conversation where they had talked to someone else explaining how they had made it. But had that conversation never happened, we never would have known, right? We could have used these and never even thought a moment about this. So I'm going to skip ahead. I had a thing about clip skip in here, and it's kind of cool. And if you want to talk to me about it later, we can do it. But I kind of want to think a little bit more generally, and I want to pull back away from stable diffusion, just a little bit. What we're looking at is, I guess I want to pop it here first, is that the idea that humans get weird when tools accept language as an input. And the tools have to get a little weird too in order to sort of accept language as input. And with stable diffusion, you have this strange space where they have trained billions of images, right? 2 billion images roughly for stable diffusion 1.5, and assigned to them sometimes human generated categories, sometimes machine generated categories, but that images, like, sometimes the category will be something that's in the image, so mountainside. Sometimes it's a characteristic of the image, in this case warm lighting. Sometimes it's a characteristic of the style, in this case Dadaist. All of that gets chunked down into about this 2 gigabyte weight of matrices, and you have this space where it is not entirely clear whether or not what you are exploring is correct output or error. And it's exceptionally difficult to particularize that in Stable Diffusion because the number of images and because the complexity of the tool is so high. But in that tool that I got into last year, DALL-E Mini, which was this much reduced version of the same thing, or of a similar pipeline, you actually can find some of these regions. So I don't know if folks will remember last year, but when DALL-E Mini came out, people discovered that with certain kinds of input, it returned women in saris. Which is sort of a strange thing. And sometimes there's a lot of inputs that will get you there, but I chose, in this case, one's just the URL to the Wikidata entry for the city of Dresden. The other one is just a snippet of the XML schema for a person. And if you plug those into DALL-E Mini, you will generate these images. And I think a lot of people had a sort of like ways that they made sense about it. They talked about there's a lot of unlabeled data that comes in, and these image generators were deal very poorly with poorly labeled and unlabeled data. So that's maybe how it comes in. But I don't necessarily know that that's the whole story, because there's elements where the data collection is important. There's elements where the way that the model selects things is important. And also, these are not the only strange regions. One of the things that I did while I was a little bit obsessed is that I went to the online encyclopedia of integer sequences and I just started plugging them in to DALL-E Mini. So in this case, I found that there are some integer sequences that result in these sort of strange Southeast Asian junta images. Not all integer sequences will do this. There's not any particular. Some of them, if there are sequences of ones and zeros, it'll give you soccer games, which I appreciate because it's a nice joke. But there's other ones where it will give you images of fake chemical models. But here, this is a very strange space, and we don't necessarily have a good holistic sort of human tractable sense-making reason why this happens. But it's at least possible to explore it. And one of the things while I was doing that was I said, okay, well, I put in a bunch of imager sequences. What happens if I put in a bunch of zeros? And here's a fun thing. If you put in 50 zeros, when you start hitting 50 zeros, just 0, 0, 0, 0, 0 in a row, the images that you get are desert. It's poetic. It doesn't make any sense. And the same thing, if you as you go out to 300 zeros, you will continue that. The pattern continues. It in fact gets more desert-like. You see fewer houses and you see more landscape as you add zeros. I don't have a good reason why that happens. I just know it does. One of the things that I did to try and explore this was to say, okay, well, as we discovered when we typed in Apple to Stable Diffusion and it gave us an Apple computer, some things have sticky meaning in these systems. So we discovered, my friend Jared Phillips found this out, discovered that if you type in Calvin Coolidge as part of the prompt, you almost always get images of him being dour, right? And Silent Cal sitting down for a portrait, probably mostly because that's where the data came from. But one of the things that we realized is this can be used for a sort of some semiotic stickiness. And so what I said was, okay, well, let's let them fight. So I typed in strings of zeros, and then I put the string Calvin Coolidge. And then I realized also that if you type in Jesus into DALL-E 2, it's also a very sticky meaning. And so you've got this sequence where this was something that I did last year, and I didn't actually keep the individual ones. You can imagine that they sort of interpolate between the spaces. And so you have this strange situation where, like, I don't think we have a good explanation for what's happening here. I'm interested to hear one. I'm interested to hear people's crack at them. But I think, what time is it? So it's 1:16. So I kind of want to I started with a story. I want to end with a story. When we talk about new tools like this, we often, even in sort of the celebratory discourse, we bring up the metaphor of Prometheus, and technologists like Prometheus because he was punished for knowledge. The idea was that Prometheus gave man fire, and the gods were upset about that because it took away their sort of control over when man got fire, and they had him lashed to a mountain, and a vulture would eat his liver. Very peculiar that it's his liver. We'll get to that in a second. How a vulture eat his liver for eternity. And that's an interesting story, and it's flattering to technologists because it makes them feel like the victim and also the savior at the same time. It's really a good space to be in. Except one little problem. That is not why Prometheus was lashed to that mountain. So Prometheus did in fact upset the gods by bringing tools and other things to human beings, and there are a lot of stories about tricksters and bringing things that humans recognize as important to humanness to them. But Prometheus was actually punished because he allowed humans to trick Zeus. He taught human beings to take a carcass of the carcass of a steer and to pull out all of the innards, which is what the gods wanted to eat. That was the good stuff, right? The liver, and replace it with cartilage and with bone and with all the gristle and all these things that no one would want to eat. And they dressed it up nicely. They left it out. Zeus swoops down, accepts the sacrifice, which means that he's now bound for whatever reason to accept this same sacrifice for all eternity, and gets very upset at Prometheus and then sends him off to have his liver, his innards eaten by this vulture. So it is important, I think, when we are talking about these digital image generation tools, to remember that Prometheus was punished for faking provenance. He was punished for faking where this sacrifice came from. And we should think a lot about perhaps where these images come from and what we're doing with them. And I know that I didn't get to talk about that in this workshop, but like, I'm very happy to talk about more about that later. So I want to say thank you to folks that came. This space moves very fast. As I mentioned, way at the top, the GPT-4 demo is live right now. So when we get done with this, if you want to go over there, you can do that. Finding resources and help is hard. If you look at this, meme on the right-hand side, you will get a sense that a lot of the spaces where you're trying to find help, like on Discord and things like that, are not safe for work. And even if you stay out of the channels that are not safe for work, they're not something that you want like loaded up, because the safe for work image channels are just going to be scantily clad, whereas the not safe for work channels are going to be not clad at all. And so please reach out to me if you want to try and find like a resource or a site that like isn't gross. And because I've tried to find one to not a lot of success, but and also I know we didn't talk about them too much, but like, do not lose touch of the moral questions that exist in this space. And I think that's it. I think I can open to questions now.
Well, first off, I think we should just like give you a big round of applause. Thank you so much, Adam.
Yeah.
And folks are asking for subscriptions to your newsletter.
My newsletter, I gotta write one. All right. No.
So yeah, so if folks have questions either in the chat or want to turn their microphones on and ask, we've got about 10 minutes left, and I would love to take this opportunity for folks to do this. I know we have a class that joined us. I don't know if Claire is still here, but if any of your students have questions too, that would be rad.
Yeah. If no one has questions, I can go back and do the clip skip stuff. Let me see. I'll fire that up while people have questions.
I think people are just like digesting all the
information. Yeah. So one of the things
oh, we'll you got a question.
Oh, got a question. All right. I'm
saved. Can you weigh in on the artist versus AI art debate?
Okay, yeah, I can. So implicitly, because we're using Stable Diffusion 1.5, we've already weighed in a little bit. Simply by the fact of using it, I think it's really, really quite tricky. The first thing that's important to recognize is when you're thinking about issues like this is we want to think about the terms of like in terms of desserts, like who deserves what and that sort of things. But we really should think about it in terms of distribution, like who is making money. And so if we have a lot of these people building things like Stable Diffusion or DALL-E saying, oh, well, it's very difficult for us to contact all these people that have the copyrights, and we've got all this non-copyrighted information. But we're happy to take your check. We're happy to take this check that's made out to OpenAI. We will cash that. We will take that to the bank. So it becomes difficult to talk about morality in that space because OpenAI makes quite a bit of money, and these artists are not necessarily making money. Another element of this that I will put in is that we have right now this very strong kind of fight between folks that make digital art and folks that are mostly amateurs making AI art. Right? We'll use that word right now, and a lot of this is like people fighting who shouldn't be fighting, because while these two people are fighting, Microsoft and OpenAI are inking a deal with Getty Images. They haven't announced it, but they are. And I saw your Midjourney question. I'll get to it. And so they haven't announced that they're working with Getty Images to make stock photos from Getty's library using DALL-E. But that's like the that's the big issue. Right? It's Microsoft writing a check to Getty for $1.5 billion, and then people who make stock photo images being out of a job. Right? That's like the big picture. Like that's like the huge amount of like what's being sort of like taken out of the community. And I think a lot of this, like people getting online and being like, I put up a picture of a person and I think it's art, and really what they did was they put in a prompt. I don't, that's not as much of an issue for me. The other element of that is that, like, when we think about provenance, that story that I told about Prometheus, we have to think clearly about how these images come into the data set. But honestly, from my perspective, looking at the discourse, the way that people in the digital art community talk about these tools is messed up. Like, it's wrong. Like there's lots of really popular posts about like how AI art is just collaging, which is just flat out wrong. Like not morally wrong or anything like that. It's just technically incorrect. And it just, you're describing a system that doesn't exist. And that I think is like a short way to weigh in on that. The Midjourney question. So just personally, when I was starting to do this stuff, I didn't sign up for Midjourney because you needed a Discord account to do it. I think Midjourney is really interesting because, unlike Stable Diffusion, there are a lot of guardrails that are put into Midjourney to help you produce something pretty that you don't even notice. And so you can get really outstanding, really cool images, but some of what's happening is explicitly under the hood, and you're not given a lot of access to that. Ryan asks, have you been integrating these processes with your work in HCDE? I think a lot of what this is me trying to articulate how we talk about these tools when we work with them. So we're seeing, and in fact, I'm reviewing a couple papers about like people using these tools for brainstorming, or people using these tools for idea generation in some other way, or some other element of design, and something that's very important to HCDE. And the issue, I think, sometimes is that unless there is a lot of careful attention paid to what the tool actually is and how it's working, we run the issue of like speaking nonsense about it. And so you have like, and we're in this weird transition because like previously you had a lot of work where the way that we would talk about it would be mostly about contingency. We would load up this thing and it would be like, look how random it is. Look what like it reaches for. Look at all these, these sort of different things that pop up that I didn't think I put into the prompt. And we're kind of moving away from that because these models are getting a little bit more sophisticated, and we're having to like act like we're having to like try to make it be random as we interact with it. And that interface, that change from we can talk about it as a source of contingency being added to the project to it is much more regularized. I don't know how folks are managing that transition, but my hope is to try to make a sense of like how we speak about these tools in order to follow that. Does that answer your question?
Got a couple of thank you so muches, so I'd say yes.
Cool.
Thank you so much for identifying that so much of it is like almost like a rhetorical issue where like
Yeah.
people should really be unified against together to sort of be like, let's keep our eyes on Microsoft, guys.
All right, so Sage has a question, but like on the rhetoric thing is important because it's also when you try to think critically about how natural language actually interfaces with these tools, I hope, will apply that same process of thinking to how people talk about ChatGPT. All right, Sage says, how pumped are you about the future of pirate AI? All right, so we're already living in it. Okay, so this Stable Diffusion 1.5 was produced essentially, it was almost an act of piracy. That's perhaps mean. So this is being recorded, but sorry, EMAD. Almost an act of piracy. They produced this and they distributed it around the world. And now you have embedded this gigantic image model that's very difficult to eradicate. And people are building other kinds of models on it. Like there's a distributed image generation processing protocol now where you can sign your machine up, sort of like SETI at home, to generate AI. So like this is being embedded in a lot of different places, and it's almost all pirate work right now. So I'm a little bit pumped. It's scary, and like it's very difficult to like keep any kind of control, but the way that we imagine like, oh, a very responsible big company would keep this behind a moat and would not let someone generate an image of like there is a so one of the other images that it's a whole nother story. I'll talk to Sage another time. Sage is great. Everyone should follow Sage. He's not on social media, but follow him anyway. I don't know where I was going. Anyway, we're already in the golden age of AI piracy. Yeah. And like there's all kinds of other like leaked models. There's all kinds of other like things that are generated like by small networks of people that are being distributed sort of very narrowly. Like there's a lot of weird stuff going on in this space. Oh, I know what I was going to. So very end, we have this idea of like these big companies are going to put these models behind a moat and they're not going to let you generate an image of like Barack Obama naked or something like that. And the problem is like this tech doesn't work like that. Right, we already have known implementations that can be run on a desktop computer. You can't gate that. You can't gate it. And so we are really in a space of like, do we distribute tools to do with this, or do we pretend that Microsoft can keep the moat up? And there we are.
All right. I think we got time for like one last very quick question, if possible.
If you ask a question now, you get the last word.
People are saying so great, so thanks. If you had one piece of advice for folks who want to get started on this, what would you tell them to do going into it?
Ooh,
gut impulse.
Start small, be weird.
Start small, be weird. Excellent.
Yeah.
Well, that is the perfect note. Adam, thank you so very much. Thank you to everybody who came out. I will be sharing out the recording along with the link to the slides, and this has been absolutely phenomenal. So thank you so much, Adam. I'm excited to go play with all this stuff.
Yeah.
So, but yeah, have a great day, everybody. And I will stop the recording.